Okay, welcome back. I'm glad you're here. This is our second video in our Introduction to Trigonometry section, and we're going to start talking about the rectangular coordinate system. And so the rectangular coordinate system is just a fancy name for what you've been graphing on for a long time. All right, so we take a plane and we divide it into four parts using an x-axis and a y-axis. The four parts are called quadrants, and they start here with quadrant 1, quadrant 2, quadrant 3, quadrant 4. The points in each of the quadrants have an x and a y value. And in quadrant 1, x and y are both greater than 0. In quadrant 2, x is less than 0, but y is greater than 0. In quadrant 3, they're both less than 0. And in quadrant 4, x is greater than 0, y is less than 0. Also important to note that if you're not in a quadrant but on an axis, if you're on the x-axis, that means your y value is 0, and on the y-axis, your x value is 0. All right, so let's go ahead and start talking about how this gets us closer to knowing about trigonometry. So we're going to start out by drawing an angle in standard position. So whenever you see these words in standard position, it means something very important. It means that on a rectangular coordinate system, you're going to draw an angle. And it's very important that the initial side of the angle is always the positive x-axis. So let me write that down. Initial side. Oh, I'm not spelling well. The initial side is always on the positive x-axis. And because it's part of an angle, we draw it as a ray. So don't forget the arrow. Right? Then we draw a terminal side. And it's important to notice that our angles are always drawn with a counterclockwise rotation when the angle measure is positive. Okay, so let's keep this in mind. So if I ask you to draw an angle that is 60 degrees in standard position, you would draw that, and then you would draw this arcy arrow in between the two rays, and you would write 60 degrees. All right, so that's an angle in standard position. Now, a funny thing happens. Before, when you learned trig, your trig was all in a triangle, and you never had angles greater than 90. In this trig, the sky's the limit. So we're going to have angles that are over 90, that are over 180. We are going to have angles that are negative as well. All right, so let's go ahead and practice a couple that are not our typical 0 to 90. So if I asked you to draw an angle of 170 degrees in standard position, you would draw your axes, right? And your initial side is always here on the x-axis, and then you would say, all right, this is 90, all the way to here would be 180, so we would estimate right about there, right? So it's clearly an obtuse angle, and then we would draw the curvy arrow in between and write 170 degrees. All right, makes sense. Let's go ahead and look at one that's greater than 180 degrees. Let's graph one that's 310 degrees. And this is kind of unusual because it doesn't look like angles we've ever drawn before, but you'll get used to it. All right, so here's our initial side, positive x-axis, 90, 180, 270, 310 is going to be here, right? 270, 40 past 310. And it's really important that you draw your angle this way. All right, so it's a 310 degree rotation. Interesting thing, before I get into negative angles, I want to talk about two angles are called coterminal when they have the same terminal side. So this is a good time to introduce this. All right, so a 310 degree angle has a terminal side right here. But if we did a negative rotation, so let's say that we have the same initial side, but instead of going counterclockwise 310, if we went clockwise 50 degrees, we would call that a negative 50 degree rotation, and it turns out that 310 and 50 are coterminal. And an easy way to find coterminal angles is if I give you a positive angle, you simply subtract 360 from it. Likewise, we can have angles that are greater than 360. So let's find coterminal angles where they're both positive. So let's start out with a nice easy one. Let's go to a 30-degree angle. So here's a 30-degree angle, right? The arrow goes this way. And so if I go around one more time, which I can, there's nothing wrong with it. So from 30, I'm going to go around 360 more. We see that 30 and 390, so I have to have two arrows here. This actually goes to that, and that goes to that. So 30 and 390 are coterminal angles. All right, we'll practice that some more in class so you get the idea of it. All right, then I have just a couple more things that I need to get to. One is to talk about distance in that rectangular coordinate system. As a quick review, if I'm on a number line, the way we find the distance is we subtract the two values and take the absolute value. So if this is A and B, we can take A minus B, absolute value, and that'll get us the distance. All right, that's an important concept that will come back many times in your mathematical career, so don't forget that. But today's topic, we're talking about what about distance in the coordinate plane. And so back in geometry, maybe in algebra, you learned this thing called the distance formula. And the distance formula is really truly just a glorified version of the Pythagorean theorem. So if you want to know how far it is from 3, 1 to 6, 5, right? If you drew a right triangle that had the distance between them as the hypotenuse, and you counted the lengths of the sides, you could simply do 3 squared plus 4 squared square root, and you get 5 is the distance. All right? But it's not always convenient to draw in a grid, and so we need to be able to find the distance between between 2 points without drawing it. All right, so this is where the distance formula comes in. The first ordered pair we call x1, y1. The second ordered pair we call x2, y2. And here's the distance formula, and it's the square root, the distance between these 2 points. We subtract the x's and then square it, and then we subtract the y's and square it. Add them together and take the square root. All right, easy as that. Again, we'll practice that a lot in class. Last thing I want to talk about is circles, and specifically something called a unit circle. So we remember from geometry, x squared plus y squared equals r squared was the standard form of a circle with these characteristics. The center was at the origin, and r is the radius. So for example, x squared plus y squared equals 25 is the circle with the center at the origin, right? And then anywhere you draw the radius is equal to 5. All right? So we're going to specifically talk about a unit circle where the radius is 1. So when you see unit circle, I want you to immediately think of that. All right? And you're going to be asked, you're going to be given points, and the question is going to be, is it on the unit circle? All right? So, for instance, if I have a unit circle, I know exactly 4 points that are on that unit circle, and I hope that's pretty easy to see that we call those the corners. At the corners where the unit circle intersects the axes, because the radius is 1, we know the ordered pairs that are represented at those points. All right, but what about if I give you, for instance, an ordered pair 3/5, 4/5, and the question is, if I plotted it, would it land on the circle or not on the circle? Okay, so sometimes we talk about an ordered pair satisfying an equation, and all that simply means is that if you plug in 3/5 for x and 4/5 for y, will you get 1? Okay, so we're just going to go ahead and do the math. So we get 9 over 25 plus 16 over 25, and sure enough, that adds to 1, and so yes, you can say on the circle. Okay? That's all I have. A lot of stuff may not seem connected, but I promise in the days to come it will all come together. Thanks for listening. See you in class.